Now for some hands-on, page 82, we're going to take a look at this. And I see they have the numbering a little bit off, but not a big deal. So, some background. Tell whether the statement is true or false. Well, this symbol is an element of. So, is 1 an element of this set? And the answer is yes, so this is true. Now this symbol is not an element. So 3 is not an element of this set. Well, it is. So this would be false. For number 3, we're asked to determine whether these sets are equal. Well, there's set C, and there's set D. Well, there's an X in both sets, there's a Y in both sets, there's a J in both sets, and there's a K in both sets. So these sets are equal. Here, order does not matter as long as they contain all of the elements. Now in number 4, we're asked to determine if this statement is true. All counting numbers not greater than 6. Well, the counting numbers start 1, 2, 3, 4, 5, 6. And is this true? Yes, this is true. Number 5. Answer true or false of the following statement. Now, this is sort of in set builder notation. X is an odd integer greater than or equal to X, less than or equal to 46. So the first odd integer after this even integer would be 35, 37, 39, 41 is missing. So this would be false. It's missing 41. Now on page 83, we're dealing with sets and subsets. So which symbol is valid to make these statements true? Now remember, we have this symbol for is an element of, but they're not asking us to use this one today, so we'll erase that. The symbol for sets and subsets, this is the symbol for a subset, and you remember from our lesson, without this bar underneath, this is called a proper subset. That is, it has one less, fewer element than the set. But every set is a subset of itself. So this is sort of a general one. But then if it's less than the elements in the full set, we can say it's a proper subset. Only has to have one less element to be a proper subset. So here you could put actually either of these, but the preferred one, I believe, would be a proper subset. Now, when we see 15 here, there is no 15, so we would write it is not a subset. In example 3, are these sets equal? Well, this one has an A, this one has an A. This one has an F, this one has an F. This one has a D, this one has a B, so they are not equal. In order to be equal, they must have all the same elements. They may be in different orders. In looking at example 4, we have set A and we have set B. Now they're not equal, but set A contains 17, set B contains 17, and set C contains 17. There is no 11 in both. There's no 9 in both, but 23 is in both. So in a sense, set C is the intersection of set A and B, and that would give you, theoretically, set C. So the symbol, I think, closest to what we have here is that there's some sort of intersection. And it's not quite laid out the way I would lay it out, but I believe that's what they're looking for. All right, in number 5, determine the symbol that would make the expression correct. So again, this has 6, 6, 5, there should be a comma here, 4, 3. Okay, so this is definitely a subset of this. Is it a proper subset? Yes, it has 2 fewer elements, so we can use this, but you could also have used this. To me, the better would have been this. As we go on to page 84 now in our booklet, we're asked to use the subset or not subset. So this would be subset, and this would be not a subset. So we're asked, here's set A, and here is set B. Now is B what compared to, and I think they meant to put here letter A, 4 is not in A, so B would not be a subset of A. We said that an empty set is a subset of every set. So an empty set is a subset of this. Now, here we have these elements which are not here. So this is not a subset of this. For number 4, here we have a 2, and there is no 2 there. So this is not a subset. You don't have to go through all. Just find one that is not in there, then it's not. Now, for number 5, we have a 2 and a 2, a 5 and a 5, a 9 and a 9. So this would be a proper subset, or you could put the bar as the general term as subset. Okay, onto this page now. We're looking at, here is subset A, and there is, I should say set A, and here is set B. We want to see what members of A intersect or are also in set B. And you want a strategy for doing it. So you look at the first number, 4. Yes, 4 is found in both. 5. 5 is found in both. 6, no. 7, no. 8. So the only ones, and we write it using braces, 4, 5. Now remember, order is not important, but probably it's nice to put it in ascending order. As we go on to example 2 now, we've jumped from something rather easy to something rather challenging. We want to find X complement that is an intersection with Y complement. And here is our universe. There is set X and there is set Y. Now, I would suggest that a way to do this would be to first find what are the members of X complement. So I'm going to set up the members of X complement. Now here's what X is, and what I'm going to do is eliminate these members from our universe. So I have E, F, G, E, F, G, and I have 10, 11, 12. 10, 11, 12. So what I have underlined in red are the members of set X, but I want X complement, those that are in the universe that are not in set X. And I now get H, I, J, 7, 8, 9. Now I'm going to do the same with Y, but I want to intersect it here. So this will be Y complement. So what I'm going to do is find out what Y would have been and eliminate Y from our universe doing what I've just done. So the members of set Y are F, H, J, 8, 10, 12. So Y complement would be those not underlined, E, G, I, 7, 9, 11. Now I've set up what X complement is and Y complement. I want to see what are in both because I want to see what intersects. H, no. I is in both. 7, 9. So what I have in both of them would be I, 7, 9. That is the intersection of the complement of X with the complement of Y. And again, it takes a while to do it, but you want to get the right answer, and this is the protocol to follow. Now I'm hoping you're trying these ahead of time, and then I'm helping you if you need it. So for number 3, we're looking at D, union with set E, and then later intersecting with set F. So we're going to define this part first by listing all of the elements of D and E in one set. So now that you have defined this union, we can look up at F. We want to see intersection. So 13, no. 15, yes. 16, yes. 18, yes. So now we pick out our union, which will be 15, 16, and 18. So again, you want a strategy. Always do what's inside the parenthesis first, and then you finish it. Sort of like order of operations. And I have a little note that in the answer key later, this is incorrect there. This is correct here. All right, let's take a look at number 4. Again, we're looking for strategy. So as we looked at what we are charged with here, we want to have the intersection in parentheses here of Y and Z. So there's Y. Well, the intersection, we have a B in both. We have a D in both. No 18, no 17, 19 is in both. And 21 is in both. So our intersection here would be B, D, 19, 21. Now we want to have union with X. So we start listing. We're going to have A, B is in both already, C, D from over here, this D, 17 we need to put there, 18 we need to put there, 19 is there, and we need a 21. And it never hurts to check your work. And that looks good. Again, you want a protocol for doing this. You do what's in parentheses first. Find the intersection of these two sets. Then you're going to union it up with X. And there's our results. Now there's not only one way to do something, so there are different ways. So for number 5, U is your set of universities in the United States. Set A would be the universities with the word city as part of them. So city in A. Set B is the set of universities whose names contain the name of a president. So here is B. Now you might have some cities that have a name of a president. I don't know, but Washington is an example. I'm sure Washington is used as the name of a city every once in a while. So this would be presidents' names here. Now, what they'd like you to do is to describe the set of B complement in words. So the universe is all universities. Set A is cities that are included. And then this is A here and this is B. So B complement would be these and everything out here. So in a sense, you could write it that B is the set of universities that do not contain the name of a president. And putting it in set builder notation would look something like that. Now, you may not have needed to have made a Venn diagram, but whatever helps. So here are the different genres: news, sports, comedy, fashion, gossip, fiction, from ranking 1st to 6th. And here are the amounts of subscriptions. And we're saying set F is the set of genres that with more than 6 million subscribers. So this is more, and it cuts off here. So we've listed set F. Now, set G is the set of genres with the subscriber number between 4.6 and 14. So set G would be between 14 million, so it would start here, and 4.6. So it wouldn't include gossip because that's 4.5. So it's these two. So then what would be G complement? Well, it would be these four up here. And these could just be listed then there. News, sports, gossip, and fiction. Now, when I looked at the answer key, they included this one up in G, but it doesn't seem to be, so whatever. So in setting up number 2, we're given these letters to indicate the trees that are in this park and then the trees that are in this park. So they want us to have a union of these two. So I just went through and listed them all alphabetically. Now, for letter B, they want us to find what would L complement be. Well, we'd have to take out, and again, whatever technique you want to use, take out the E, take out the O, take out the B, and take out the P. So L complement then would be what's left. That is F, M. And that would wind up this session. It ran a little long.